Tonight's video is section 1.5, infinite limits. The homework out of 1.5 is 1 through 51 odd. So this is not a proper definition, but anyways, these infinite limits, these are limits that are approaching vertical asymptotes. These limits do not exist. So let's do some examples. An example, the limit of 3 over x minus 2 as x approaches 2. Well, if we take a look at that function, x equals 2 is a vertical asymptote. That is a factor that cannot be canceled out in the numerator and denominator. So we already know that that is a vertical asymptote. So if I sketch that out, in fact, I'm going to do that here in a minute. If I'm approaching a vertical asymptote from right and left, because it doesn't say plus or minus, it's either like this, or like this, like this, or like this. But no matter what, it doesn't approach some value. Therefore, it does not exist. And there's nothing I can do to that to simplify it so I can take the limit. But if asked, what is the limit of 3 over x minus 2 as x approaches 2 from maybe just the right or just the left? Well, first off, it still doesn't exist. From the right, it either goes up to the vertical asymptote or down. It still doesn't exist. But when they ask you from the right or left, they want to know, they want you to determine whether it's approaching positive or negative infinity. It still does not exist. But they want you to tell the reader that at least you understand that it's approaching a positive or a negative infinity. So you need to figure that out. And how are you going to do that? You're either going to do it by graphing, because you know what the parent function and you can determine from the right or from the left. Or you're going to do it by a table of values to determine if it's going to positive or negative infinity. So let's take this same function and let's graph what we know. We know that the vertical asymptote is 2, because that's what I'm approaching and from the right. So at 2, I'll make a vertical asymptote, and I'm going to give myself a little arrow stating I'm approaching it from the right. Now I happen to know that parent function, that's 1 over x, that's been horizontally shifted to the right 2 units and vertically stretched by 3, but let's pretend you don't remember that. You do know there's a vertical asymptote, and they're asking you from the right. So then I'm going to make myself a small table of values. 4, 3, and then 2.5. 4, 3, 2.5, but I want that in fraction form. And what am I going to do? I'm going to substitute that or evaluate that in the function. F of 4 is 3 halves. F of 3 is 3 over 1, and f of 5 halves is 3 over 5 halves minus 2, and I have to simplify that until I multiply by the reciprocal. So lots of algebra. And then what I do is I take that output and I just briefly sketch it. So at 4, I'm at 1.5. At 3, I'm at 3. At 2.5, I'm way up even higher. So therefore, what I know is the limit of 3 over x minus 2 as x approaches 2 from the right is positive. It's approaching positive infinity, because that's what the table does, is I'm approaching 2 from the right. Does it exist? No, it still doesn't exist. But when they ask you from the right or the left, you must tell them if it's positive or negative infinity it's approaching. Let's try example number 42 from the textbook. And there's such a variety of algebra, there's no way in the notes I can go over all of that. That's why you're going to do that in class. But I will go over a couple. 42, not one of yours, you have the odds, this isn't even. The limit of x squared minus 1 over x as x approaches 0 from the left. Well, the first thing I can do is I can separate that into 2 limits. The limit of x squared as x approaches 0 from the left minus the limit of 1 over x as x approaches 0 from the left. Well, that one I substitute in and I get 0. That I try to substitute. I get an undefined, no. And I'm asking you from the right or left, so I want to know if it's positive or negative infinity. I know it's approaching a vertical asymptote. The vertical asymptote is 0. That's what I'm approaching. So I must try again. So I know what 1 over x looks like. We learned that in pre-calculus, that the asymptotes are at both of the axes, and the parent function is in quadrant 1 and quadrant 3, and it's hugging those asymptotes. And so this limit here, the limit of 1 over x, there it is graphed, as I'm approaching 0, here is 0, from the left. As I approach 0 from the left, it's approaching negative infinity. So 0 minus, what is the limit of this? The limit is what I'm answering right here. It's negative infinity, and which equals positive infinity. Be careful of those signs. The answer to this limit is negative infinity, but there's a minus here. So it's positive infinity. Does the limit exist? No. But that's not what I'm exactly asking you. I am, but I'm not. 44, here's another example. The limit of negative 2 over cosine of x as x approaches pi over 2 from the right. Well, if I just substitute that in, that's negative 2. Cosine of pi over 2 is 0. So because if it didn't ask me this, right here, I would say undefined. Does not exist. Does not exist. But because from right or left, I know this is an asymptote. Why? Because cosine of pi over 2 is 0. That means pi over 2 is my vertical asymptote. But since it's to the right, I want to know if it's positive or negative infinity. So this one, I'm actually going to manipulate the equation just a little bit. I can go ahead and take the reciprocal, the limit of negative 2 times secant x as x approaches pi over 2 from the right. Now I just didn't pull this out of thin air. Look below, I'm going to have this graphed. So I know secant, I have to sketch out cosine. So here's cosine from 1 to pi. Starts at 1, goes down to negative 1, goes back up to 1 at 2 pi. Right? And then secant is where I draw in the vertical asymptotes at pi over 2 and negative 3 pi, not 3 pi over 2. They share those points. This here happens to be the secant. And this piece here is the secant. And this piece here is the secant of one period. And of course it continues. But all I care about is the limit as I'm approaching pi over 2 from the right. As I approach pi over 2 from the right of the secant function, not the cosine. I'm really doing the secant. I have to sketch the cosine to get the secant. It's really negative pi over 2. So it's negative 2 times negative pi equals positive pi. Careful of those signs. Does this limit actually exist? No. $44. I'm going to do it again. Again, if it doesn't have the plus or minus, same exact thing. I can go ahead and try to do this, but the secant of pi over 2, again, let's take out the unit circle this time. Pi over 2 is here. That's 0, 1. What is secant? It is the reciprocal of cosine. Here's cosine. Cosine is 0, right? So I can make that a fraction, take the reciprocal. No, that's undefined. I know that's a vertical asymptote. Because it doesn't say plus or minus, I just say does not exist. Again, why? Because I was asked x approaching pi over 2, not from the right or from the left. Thank you.